was like, is it what else is gonna be like I knew that and like what other concepts. She didn't say yeah, we not like tests, but like prompts kind of.
Did you start it?
Not yet. Or we're starting kind of right now.
That's what it's stuff. He's like, no, everything I went over.
I'm gonna see Sarah.
And then we were like, and somebody asked me, was like,
Okay, let's just start with this. I think we're just going to go through these. Question 1, we have an integral from, of x squared sine x dx. I'm going to use tabular method. Integral by parts. So u dv x squared and sine x. 2x, the antiderivative of sine x is negative cosine x. Good. 2, and the antiderivative of negative cosine x, negative sine x. Then 0, and that's cosine x. Okay. We have an x squared times negative cosine x minus 2x times negative sine x plus 2 times cosine x. So if you do all of that and put it all together, you're going to get negative x squared cosine x plus 2x sine x plus 2 cosine x plus constant of integration. All right, that's question 1. Let's get question 2. I think question 2 is similar. Question 2, we have the antiderivative again of x squared e to the 3x dx. Again, this looks like a good candidate for the integral by parts. Tabular. dv x squared. No, let's not do it that way. Derivative 2x integral 1/3 e to the 3x. Derivative 2 integral 1/9 e to the 3x. Derivative 0 integral 1/27 e to the 3x. Multiply. We get x squared 1/3 e to the 3x minus 2x 1/9 e to the 3x plus 2 1/27 e to the 3x plus constant. Okay, clearly I can factor out an e to the 3x, but I also want to factor out the smallest fraction, which is 1/27. So I'm going to factor out 1/27 e to the 3x. See what happens here. See, 1/3 divided by 1/27 is the same thing as 1/3 times 27. So 9x squared minus, okay, we have 1/9 divided by 1/27, which is 1/9 times 27. 1/9 times 27 is 3. 3 times 2x is 6x
Sorry.
plus 2. Three. So let's use a general power rule. That's a little bit of a little misleading, because really you should just be taking the integral of this. And then we're going to make a note about when that's going to happen. Really, we should be using the U substitution. So U is equal to 4 minus 9x squared. du is equal to negative 18x dx. I'm going to note that I have an x dx. So that x dx is going to be replaced with negative 1/18 du. So the integral becomes u to the 1/2 power times negative 1/18 du. You may want to simplify that. Okay, 1/2 plus 1 is 3/2. Reciprocal of 3/2 is 2/3. 2/3 times 1/18. You know what? I'm not going to do that in my head. Negative 1/18. 2/3 u to the 3/2 plus c. Okay, so factor that's a 9, negative 1 over 27.
Yeah.
And of course u was 4 minus 9x squared. This may or may not be written with a fractional power.
Square or cube?
Square root.
No, it's cubed on the inside.
Yeah, it's a square root of a
Oh,
cube.
okay.
Square root of a cube. Or the cube of a square root. But usually a square root of a cube looks neater. Four. Another evaluate the integral. Oh, by the way, the general power rule was right here. That's where I use the general power rule. Question 4, 0 to 1. X root x squared plus 1 dx. I'm just going to do the antiderivative first. Let's deal with the antiderivative. Okay, so antiderivative of x root x squared plus 1 dx. We're going to use a U substitution. Okay. Where u is equal to x squared plus 1, du equals 2x dx. And notice I have a u and a dx. So that x dx, I'm going to replace that with 1/2 du. So the antiderivative becomes u to the 1/2 times 1/2 du. Which is 1/2 times 2/3 u to the 3/2 power plus constant, which is 1/3 square root of x squared plus 1 cubed plus constant. Okay, that's only the antiderivative. Now I have to solve the definite integral. So the definite integral from 0 to 1 of the same, that's going to be equal to 1/3 the antiderivative, sorry, just the antiderivative from 0 to 1. All right, substitute things in. You're going to get 1/3 square root of 2 cubed minus 1/3 the square root of 1 cubed. See, that's 2 root 2 over 3 minus 1/3. I guess you could write it as 2 root 2 minus 1, the entire thing over 3. Take a quick pause here so you can catch up. All right, let's look at number 5. You have the integral from e to 4e, 1 over x dx. It's supposed to make a lot of students uncomfortable to have e and 4e over there.
It does.
It worked. Okay. What's the antiderivative of 1 over x? Natural log of the absolute value of x from e to 4e. That's going to be equal to the natural log of, well, e is 2.17, so it's positive. Which is kind of weird, right? Well, I can turn this into a ratio. Oh, look, the e's cancel out. 4 is 2 squared, right?
Yeah.
It goes back to, we didn't talk about this here, but they used to have charts that had the natural logs of numbers and things. And they wouldn't have the natural log of 4 because all you would do is take the natural log of 2 and multiply by 2.
Oh.
They have the natural log of 9, so you just take the natural log of 3.
And you multiply by 2, right. They wouldn't have natural log of 9. Yeah. They'd have mostly natural logs of like prime numbers.
Like 7.
Yeah.
That's gonna be it. Why don't we have that now?
Because you have a calculator.
Yeah. Alright, well, super complicated. Continue.
Right, 6 is a 3-part question. Okay. 6, the first part is a trapezoidal approximation. Okay, do we like doing this in the chart?
Sure.
Okay. The first interval goes from 0 to 1, right? Second interval goes from 1 to 2, right? Third interval goes from 2 to 3. Last interval goes from 3 to 4. Okay, so for a trapezoidal approximation, let's do the width of each one. All the widths are 1, right? Okay. And then for the height, remember for the trapezoid, you're going to use 1/2 base 1 plus base 1 plus base 2. So we'll do this first one. It's 1/2 of 1 plus 4. Which is 5/2. This next one is going to be 1/2 of 4 plus 8. 4 plus 8 is 12. 1/2 of that's 6. Next one's going to be 1/2 of 8 plus 5. 13/2. Last one's going to be 1/2 of 5 plus 3. It's 4. No. This one I want aligned to the right. This one I want aligned to the right. This one I want aligned to the right. This one I want aligned to the middle, right? Middle. Middle. That works. Okay, so integral from 0 to 4.
What are B1 and B2?
That's going to be f of 0 and f of 1.
Wait, what did you get to get in 6 and 1 and 2? You used 2 and 8. No. Which one? Yeah, that's what you just the 14.
Okay, this is going to be equal to 1 times 5/2 plus 1 times 6 plus 1 times 13/2 plus 1 times 4, which is equal to, let's see, 10, 9, 19. This is really an interesting problem because notice it's not the integral of f, it's the integral of f prime of x, right? So actually, we know what this is using, we can do this using the fundamental theorem of calculus, right? Using the fundamental theorem of calculus, this is equal to, sorry, maybe I should write it like this, 0 to 4 of f prime of x dx. We know that that's equal to f of 4 minus f of 0, right? And that should be equal to 19. Sorry, it should be approximately equal to 19. This is kind of like putting together two different concepts from the course. Part B says, assuming f of 0 is negative 6, what would be f of 4? Okay. F of 4 then that would be 13, right? And we're going to do the same thing for part C. Again, f of 4 minus f of 0 is approximately equal to 19. This time they're telling me that f of 4 is negative 6. So 25. So f of 0 looks like negative 25. I think this might be a good place to kind of pause for a couple seconds and take questions if you have them.
Back at the chart, when you have b1 plus b2,
Mm-hmm.
you said it represented the f of 0 and f of 1. What exactly do you?
What is that? Well, we're looking at a trapezoidal method.
Okay.
So this right here, if I can highlight that, this right here is specific to a trapezoidal approximation.
Okay. Thank you.
This was the test that I failed.
That would do it.
That's how I get it. I think it's the first test I did for a while. Or I might have failed this one. I don't remember. I do all like one test.
I don't remember. Run reviews so bad.
Okay, any questions before we move on to 7? Good. 7 is more fun. That's not nice. 7 is more fundamental theorem question. F of x, big F, is equal to the integral from 1 to x squared t cubed plus root t dt. And we're supposed to find f prime of x. Well, f prime of x is going to be equal to the derivative of the integral. Okay, derivative of the integral, remember what we do. We substitute and then we multiply by the derivative of the limit. So we substitute x squared cubed plus square root of x squared times the derivative of x squared minus 1 cubed plus the square root of 1 times the derivative of 1. And if you remember that as long as you have a constant, that derivative is going to be 0, you actually don't have to do this part of it. Okay, x squared cubed is x to the 6th power plus x, everything multiplied by 2x. So I think you could factor out another x, right? So 2x squared x to the 5th plus 1. Okay, 8, average value. And this is just a definition of a average that we use in the calculus class. Well, actually everybody uses it, but you don't really learn about it until calculus. But that is an average. So in our case, the average is going to be equal to the integral from 0 to 2. Actually, before we do the integral, we should do 1 over 2 minus 0. Integral from 0 to 2, the average of 3x squared minus 2. The average is half of x cubed minus 2x from 0 to 2. Which is half of 8 minus 4 minus half of 0 minus 0. Hello. Okay, I'm going to send someone to pick it up. Are you at the front door of the school? Okay, I'll see you there in a few.
Shantae really wants to go.
Shantae, why don't you go?
I went last.
The average is 2, right?
What's the total?
Oh, I've already paid and tipped.
Yeah, I assumed that because
Use a sign for him though.
Just scribble.
Maybe you should
Right,
give her the stamp.
Give her this. Okay, that's 1 through 8. 9's going to be kind of a long one, so I think we're just going to pause it here, okay? Pause.
We're done.
Pause for pizza.